monomial, binomial, trinomial, polynomial. Okay? A monomial is one term. A binomial is two terms, and so on and so forth. A trinomial is three terms. A polynomial is 4 plus terms. It can be 4, it can be 5, it can be 6, and so on and so forth. It is important to understand and remember the terminology. A monomial is one term. Here's an example of a polynomial. 4x to the fourth minus 3x squared plus 5x minus 10. So all of these, all are polynomials. All of them. This is a specific type with one term. This is a specific type of a polynomial with two terms. This is a specific type of a polynomial with three terms, and so on and so forth. Okay? Now, we already know the degree of a polynomial. Anybody remembers how we determine the degree of this polynomial? Is?
By counting it, looking at the exponents.
So the degree is?
Yeah, the degree here is 4.
Indeed. That's the degree. And if you remember, we call this the what?
I can't remember.
The leading term. And we call this what? Very important terminology. We did this over and over. So this is the leading term, and this is the what?
Coefficient.
Leading coefficient. It's the leading coefficient. Very important. You will see in later classes why this is important. So in this way, we determine the degree of a polynomial, trinomial, binomial. However, what about the monomial? So here's one monomial, 3x to the fourth. Of course, it has degree 4. But what if it has more than one variable? What if it has 3x to the fourth, y cubed, z squared? In this case, because it's part of a monomial, the degree will be calculated by adding all these powers of the variables only. Even if I have here 3 to the 10th power, it doesn't mean anything. So the degree here is 4 plus 3 is 7, plus 2 is 9. If it has only one variable, the degree is the power of the variable. If it has more than one variable, then the degree will be the sum of the degrees. If it's in one monomial, what if I have a combination? Let's say, what if I have a binomial, like 3x to the fourth, y cubed squared plus 4x to the fifth, y to the third plus 2xy. What if I have something like this? Then how do I determine the degree? So I still have to determine the degree for each monomial individually. So this piece will have degree 6. This piece will have degree 8. This piece will have degree 2. I added the powers of the variables, 6, 8, 2. So what will be the degree of the whole thing? Of course, like before, the largest. I'm not adding degrees among monomials. I identify the degree of each monomial individually, separately from the rest, and I choose the highest to be the degree of the entire polynomial. So this polynomial, which is a trinomial, 3 terms, has degree 8. Of course, we're not going to go that high. There is no need to do that. I just want you to understand. So coming back to our simple example, this has degree 4, this has degree 2, this has degree 1, this has degree, not power, degree 0 because it doesn't have a variable. So this has power 1, but when it comes to the degree, meaning the power of the variable, this has degree 0. So degree 4, degree 3, degree 1, degree 0. I'm not adding degrees. I'm finding the highest. And the highest transfers its degree over the entire thing. The same thing here. The highest transfers its degree over the entire thing. I'm not adding degrees of monomials. No, I only add inside the monomial. Inside each term, I add degrees. I add powers of variables. Not degrees, sorry. Okay. Good. Going back. Okay. Tell whether the expression is a monomial. Is the expression a monomial?
Yes.
Yes, it's one term. Of course, it's a monomial. The variables are, so it's a monomial. The variables are x, there is nothing else. The coefficient is 6. And the degree is 8. And that's it. Determine whether the expression is a monomial. Yes, it is. What is its degree? It's 0. Not the power of 20. The degree. The coefficient is 20. It is a monomial. It does not have variables. Therefore, the degree is 0. Not the power of the coefficient. Select the correct answer. So, now, is this a monomial?
No.
This is a monomial because it's one term.
Oh, right. Yeah.
The answer is yes. The coefficient, which is called the leading coefficient, but coefficient is 3. What is the degree? Can anyone give us the degree of this monomial?
The 9th.
The degree is 9. Very good. And that's it. Good. The same thing. What would be the degree here?
7.
Yes. Perfect. The coefficient will be -8. Good. Let's move on. Now, what type of polynomial is this?
Binomial.
This is a binomial. It has 2 terms. Just 1 second. I need to delete these videos so they don't occupy the hard drive here, so I can record yours. Okay, they're gone. Good. So this is a binomial. Perfect. The given space is a monomial. No, the given space is not a monomial. It has at least one term with an exponent. Okay, it's not a monomial. It has a coefficient that is negative. It has more than one term. The given expression is not a monomial. It has more than one term. Yes. I don't understand, but anyway. So we are beyond that. So can anyone give us the degree of this binomial?
3.
3. Can anyone identify the leading coefficient?
-3.
Perfect. Can anyone identify the leading term?
-3x cubed.
That's it. Perfect. Moving on. This is not what they asked, but I wanted to clarify. The coefficient of a monomial such as x squared or z is just 1. That's the coefficient. When we are told x squared, we are told 1x squared. When I'm telling you z, I mean 1z. And we know that for ages. Okay, now, This is something that I try to draw your attention for, from a month ago. What is the coefficient of this term?
1/5.
Indeed, very good. So please remember, we have to be able to understand that. By now, from all the problems that we went through, yes, this is it. It's 1/5. What is the degree of the term?
2.
2. Good. Very good. So let's look at the second objective. We are past this. We already know how to calculate the degree of a polynomial, but let's practice. Okay, can anyone tell us how many terms, first of all, how many terms does this polynomial have?
4.
4. Can anyone give us the degree of this polynomial?
3.
3. Very good. Can anyone identify the leading term?
5z3.
Good. And the leading coefficient?
5.
Perfect. So this is very clear to us. Careful. No polynomial can have a variable with power that is negative or a fraction or anything else but a natural number or 0. Okay? So if you see 3z to negative 2, this is not a polynomial. So all powers of the variable or variables can be 0, 1, 2, and so on and so forth. They cannot be negative or a fraction.
There's such a thing as a negative power.
Yes.
Okay.
Very good. Perfect question. So there is even a formula for, or a rule. So if I have a base raised to a negative exponent, this is basically a fraction. It's a different way of writing 1 over. So if I have, let's say, 1 over 3 to the 4th power, I can rewrite it as 3 to negative 4. It doesn't mean that the number is negative. It only means that the power is negative. Can the number be at the end a negative? It could be. If it's a minus in front, who knows? But do not assume when you see a negative power, do not ever assume that the number is negative. That's not the case. So we are using this rule. Any base raised to a negative exponent represents a condensed form of a fraction. Okay? Good. Very good question. Good. So this is not a polynomial. This is not a polynomial. Why? Because a polynomial cannot have the variable in the denominator. This we should know moving forward. 2 over x to the 5th plus 3, not a polynomial, but a rational. Rational. Why? Rational expression. This is a rational expression. It has x in the denominator. But this one is not a rational expression because x is not in the denominator. So the coefficient can be anything. So the coefficient times x is one thing, but the coefficient, oops, I meant 1 over x, this is rational. This is not a polynomial. This is a polynomial. It's 0.5x. The degree is 1, the leading coefficient is 0.5, and that's it. But this one is not. If it has x in the denominator, it's called a rational expression. Okay, moving on. Okay, got it. Good. What type of polynomial is this?
Binomial?
Binomial. Very good. Degree is?
No.
Yeah. Yes, it is 4.
Yeah, 4, because that one's 0.
Very good. It doesn't matter. It's lower than 4.
Sure.
Good. The leading term,
9.
9 next to the 4th, and the leading coefficient is 9. Okay, very good.
Oh, yeah. Right.
Good. Is this a polynomial?
No.
No, because the power is a fraction. And I know Matt is going to ask, is there a possibility? Yes. So if I have x to 1 over 9, we will see later, this is a radical. Every time the power is a fraction, this is not important for now. For now, we only need to know that this is not polynomial. But I want you to understand that when the power is not an integer, actually a natural number or a whole number, an integer can be negative, and that's also not a polynomial, right? We just talked about when the power is a negative, right? This is an integer, right? Okay, so when the power is a fraction, this is basically a radical, where the denominator is the index of the radical, and the numerator is the power of x. So 1 is the numerator, 9 is the denominator. So the 9th root of x. So this is never a polynomial. But if I have the square root of 3 times x, this is a polynomial because the square root is not on top of x. This is a polynomial, but this is not a polynomial. This is called a radical expression. A radical expression. So in a polynomial, x can have powers from 0 to you name it, but they all have to be positive integers. Good, moving on. So this is not a polynomial. Good, moving on. Okay, is this a polynomial, and how many terms if it is a polynomial?
It's a trinomial.
It's a trinomial. What is its degree? Careful, because it's not arranged. Yes, it is 4. And it is not in descending order. So the correct polynomial should be, it's not incorrect, I should say, but it's not arranged correctly. 2t squared plus 3t. This should be the correct descending order of the powers of the variable. Descending order of the powers of the variable. And yes, degree is 4. Yes, the leading coefficient is -5 over 8, and so on and so forth. Good. Now, let's take a look. This is a trinomial. All variables have power 0 or above. No fractions, no denominators with variables. What is the degree of the first monomial?
6.
Yes, the degree of the second monomial.
5.
5 and 2. So therefore, the whole thing has degree. We're not adding them. We're not adding the degrees of the terms. We choose the highest. And the highest is?
The first one.
Yes, the degree 6. So the expression is a polynomial and it has degree 6, and that is correct. Good. So let's look at the next before we commutative and distributive properties. Combining like terms. We've known this for a long time, so we can practice. Okay, so we have, where am I? Here. State whether the given pair of expressions are like terms.
There.
They are. 6 apples plus 5 apples. So they are like terms, and the sum would be?
11x cubed.
Right. Oh, that's not how I do it. I have to put x first.
Yeah.
I have a question.
Yes,
I have a question about the last question.
yes.
How is the degree 6? I'm just confused on that one.
Okay.
There's two variables.
The degree of this monomial is 6. The degree of this monomial is 8. The degree of this monomial is 2. I have to choose the highest. So it's a
Oh, I
polynomial
see
with 3
now.
terms, and I have to choose the highest degree. I'm not allowed to add. I'm only allowed to add powers inside of monomial, but then I have to choose the largest.
Okay. Thank you.
Thank you. Good. 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 Are these like terms? 8x? No, they're not, because they don't have the exact same variables at the exact same powers. Very good.